Did it, did. Notice bien, did. The normal force. All right. Hey guys, peeps, I thought I would try something a little different and actually go over the notes that I'm about to give you, or maybe in some cases have given you, so we can get a better understanding beyond the reading of it. So here we go. Normal force is just a reaction force based on Newton's third law that is pushes back from the surface perpendicular to that surface. So if I stand on the floor pushes back on me to support me with the same amount of force I'm pushing on it, thanks to my force of gravity, and the normal force just responds in kind due to Newton's third law of motion. So here we go. We have a situation here with a northeastern chupacabra, but don't worry, even though he's placed on a bathroom scale, he is caged. So you are safe, and he is safe behind it as well. Yeah. All right. The cage and chupacabra together have a force of gravity, otherwise known as weight, of 300 newtons. And it's the negative direction. So the chupacabra weighs 300 newtons. If we were to place this chupacabra on the bathroom scale, it would read 300 newtons because it's going to respond with 300 newtons exactly. So the reading would actually indicate the weight of the chupacabra, which is kind of the purpose of the bathroom scale. But we'll see that we can kind of trick the bathroom scale to show us some other readings as well, depending on the forces. Now, all this stuff over here is a very formal way of describing what's happening. I'm just going to describe it as the mostly focus on the images over here. All right, so example 1's pretty basic. Example 2, we have the crate, okay? And what we have here is someone taunting the chupacabra. We do not recommend the taunting of the chupacabra. How is someone taunting the chupacabra? They're sitting on the cage or they're pushing down the cage. Look at this, look at this. Mira. Force up down equals negative 100 newtons, which means that the scale is not reading the weight of the chupacabra, 300 newtons. It's actually reading the combination of his weight, its weight, and whatever force is pushing down. So the normal force is 400 newtons in this case. This obviously doesn't mean that the chupacabra weighs 400 newtons, even though that's the reading in the bathroom scale. Just means that the total force on that scale is 400 newtons. So the scale doesn't read weight, it reads the force that's on it. It reads the force that's on it. All right, so let's look at another situation. That's pretty easy. And in situation number 3, right here, what we have is more taunting of the chupacabra. Oh boy, we're teasing this thing. I don't think that's a very good idea. Chupacabra, its weight is on the scale, 300 newtons. Now someone is pulling up with a force of 50 newtons. So what would the scale read? Well, if 300 newtons are down and 50 up, there's only 250 newtons that are on the bathroom scale. And so it would read 250 newtons. Of course, does this mean that the chupacabra weighs 250? No, it just means that the scale has this reading because its force of gravity, its weight is on the scale. Someone's pulling up with 50 newtons, leaving 250 newtons on the surface, and that surface responding in kind with 250 newtons. All right, another situation. Wonder what we have next. All right, well, we have a situation where there's more taunting of the chupacabra. Oh my gosh, look at this. Now we've got someone pushing down on the cage with 100 newtons and someone pulling up with 50 newtons and probably creating quite a ruckus in there. I think this thing is starting to get really pissed. The force of gravity is still 300 newtons acting on the chupacabra in the cage. Chupacabra still has the same weight. But now we have a force down of negative 100. So over here, what we have is a total of negative 400 down on the scale, but someone's pulling up with 50 newtons. What does that mean? Well, what's left behind on the scale is 350 newtons. That's it over here. So the scale would read 350 newtons because of the combination of all these forces on that surface, and it responds by pushing up with 350. All right. Think this is easy? I think so. We got one more case. Example 5. We have, oh my gosh, what a weird taunt. This is really starting to get crazy now. We have, yes, the force of gravity still, the weight of the chupacabra, 300 newtons in the down direction. Now someone's pulling at an angle of 30 degrees. Oh my gosh, how can we handle that? Well, we know how to handle angles, of course. We break it up into vertical and horizontal components, like we did with velocity in projectile motion. So what this means is that if we're pulling at an angle, part of that force is pulling this way, horizontally, see I'm moving horizontally, and this way, vertically as well. Well, which one are we concerned with the normal force? Of course, it's the vertical one. So we got to ask ourselves, how much of this 80 newtons is going to be responsible for pulling up off of the scale? And if we look, I'm going to zoom out for that. We have to look at this triangle here. Maybe I should actually zoom in on it. Oh, beautiful. See, so this triangle here that we would make with the 30 degrees relative to the horizontal, this part over here is the opposite side. Opposite side is related to the hypotenuse, which is this guy over here, the 80 newtons, times the sine of that angle, sine of 30 degrees. So if we look over here, that sine of 30 degrees is what we need to multiply to the 80 to get the amount of force that's upwards. It happens to be the sine of 30 degrees is 1/2. So it turns out that if we have 300 newtons down here with the chupacabra's weight in the cage, someone's pulling up with an equivalent of 40 newtons upward. Okay, 80 newtons at 30 degrees will give us 40 newtons upward, which means that the bathroom scale would read 260 newtons, 300 minus 40 for 260, okay? So that's not all though, because there's some horizontal motion here. Now or force here. Now it's possible if this scale is very slippery that we'll also pull the chupacabra and accelerate him in the horizontal direction, and he'd fall off of the scale and he'd be really angry, and we don't want to do that. So fortunately, and this is the start of friction, look at all these little nubblies here. Those are really grippy. So if it's really grippy, we may be pulling in the horizontal direction, but it's possible that he'll stick there due to the force of friction and he won't fall off. And so that's what it is. We have various situations and examples. Let's go back and quickly review them. All right, we have, again, no acceleration in the vertical direction. First case was really simple. We have the chupacabra on the scale, normal force equal to the weight. In this case, we have a force down, normal force equal to the weight plus the force down. Next situation, we have the weight of the chupacabra minus the force that's pulling up, leaving behind only 250 newtons. In the other case, we have this combination of up and down. What's left on the scale? Well, 350 newtons. That's what the scale would read. And then, of course, we have an angle. We need to bring back trigonometry. If that's the case, it's the opposite side of this triangle, 30 degrees. And that's how much we found out the sine of 30 degrees. That's the component, the amount of force that would be upwards, 80 times 30. All right. Peeps, I thank you much for being not too scared of this guy. All right. He's still behind bars, and I would just advise you not to taunt him any longer. With that, we bid you will. Morad, out.